Okay, hi, good morning, guys. We're going to get started on half-lives of radioactive substances. So I'll get started on example A. Let's read it through once together. You should have this in front of you and be writing everything that I write. You should be writing down on your paper as well. So it says tritium, whatever that is a radioactive form of hydrogen, okay? It says the amount of tritium in picograms in a sample is modeled by the equation f of t equals 9 times 1/2 to the power of t over 12. Okay, equations are always important. So I'm going to highlight that equation. Definitely going to be needing it. T represents years since the sample was first measured. So it's always good to realize what the unit is of your input. So in this case, I'm like, okay, T represents years. Okay, so what do the 9, 1/2, and 12 tell us in this situation? I'm going to start by copying down the equation 9 times 1/2 to the power of t over 12. Okay, the t I already know represents the years. So I'm just going to actually label that. Sorry. So this t and this t, the input into the equation, both represent the unit of years. Okay, what does the 9 represent? So the 9 is going to be the initial value because it's the kind of the coefficient in front of this growth rate. So 9 is going to be the initial value. In this specific case, we could go farther and say it's the initial value, the initial amount of tritium. So just adding in a few details from the problem. Some of your teachers will prefer that. Tritium. And we also know the unit, it's going to be measured in picograms. So when the sample was first measured, at the initial time, it had a value or a weight of 9 picograms. All right, next we're going to be looking at the confusing part of the half-life, which is this weird looking 1/2 to the power of t over 12. So I know you've all seen this in algebra. We're going to talk about it because it is a little bit confusing. So we're going to actually look at all of this together. Keep mixing. Okay. We're going to look at all of this together and think about what each part means. So what does the 1/2 mean? What does this t mean? What does this 12 mean? So we already know the t means years. And let's think for a second about where this 1/2 comes from. So this problem is about the half-life of a substance, or how long it takes the substance to decrease in value by half. So this 1/2 is telling us that we're looking at the half-life of a substance. And when we look at this whole piece of the equation together, the 12 is going to be really important. The 12 is going to tell us the actual length of the half-life. So the half-life of this substance of tritium is 12 years. So whatever the denominator of the fraction is going to tell you the half-life of the substance. The half-life of tritium is 12 years. Okay. Feel free to pause the video at any point if you need to copy down the notes. I'm going to move on to B. How much tritium was in the sample when it was first measured? Okay, we just talked about that. The 9 represents the initial value when it was first measured. So we can say 9 picograms. That comes right from the equation.